Coulomb's law in vector form. To understand this, let's take x-axis and y-axis. Let's take two charges Q1, for example, plus charge. Let's take a positive charge Q2 are the two charges at a distance of R1 bar and R2 bar. Okay, these are the two charges. Now, force on Q2 due to Q1. Force on Q2 due to Q1. How it looks like? Plus plus, right? It will be repelled in the what direction? In this direction. So this is your F21 bar, right? Is given as F21 bar. So let's take the distance between them is R1 to R21. Either way, it's the same. And the unit vector R21 cap. Which direction? What is the direction of unit vector? This way. Because this way you can take the direction of R2 cap. So this you can write it as F21 bar is same as 1 by 4 pi epsilon naught Q1 Q2 by distance square. What is the distance square? R21 square and cap unit vector. You have to write unit vector. So you can write R equals to R21 bar by R21. What is this? What is this? It's a unit vector form. I hope you remember this basic idea. So A cap is A bar by A. Then you will have magnitude of unit vector is 1. In the place of A, I have R21. So now how my formulas will change? So just substitute this one here. So F21 bar is 1 by 4 pi epsilon Q21 square. R21 is R21 bar by R21. So you see this now. F21 bar equals to 1 by 4 pi epsilon naught Q1 R2 cube. Until now we have R1, R21 square, R distance square you have. But when you write in terms of a unit vector, you will get distance cube into R21 bar. So this is the vector form. This is the vector form of Coulomb's law. If you take R21 as simply R, just distance between two charges, this formula you can write it as F bar equals to 1 by 4 pi epsilon naught Q1 Q2 by R cube, right, R cube, and distance vector R bar. This is how you can write. Now, what do you mean by R21 bar? R21 bar you can write it as R2 minus R1 bar. What do you mean by that? Okay, what do you mean by that? So R1 bar I have, right? So I want minus R1 bar. What do you mean by that? If this is my A bar, minus A bar is exactly opposite with the same magnitude but in opposite direction. So that's what I will do here. So I will do R2 minus R1 bar. For this I need minus R1 bar. So minus R1 bar is exactly this one. Minus R1 bar. So this is R1 bar and exactly opposite minus R1 bar. So now R21 bar is same as R2 bar minus R1 bar. I can write it as R2 bar plus of minus R1 bar. I can write it as R minus R1 bar plus of R2 bar. Simply subtraction I have converted into addition. So whenever you want to add two vectors, start from tail of minus R1 bar and go to head of R2 bar. So where is tail of R1 bar? Minus R1 bar, sorry. So tail of R1 bar is here. Where is head of R2 bar? It is here. So add this one. So this is your vector R21. So this is R21 bar. So that's what you wrote here. That's what you wrote here. So in terms of vector, I can write a formula like this now. That formula F21 bar equals to 1 by 4 pi epsilon naught Q1 Q2 by, as I said, R21 bar is this one and I want magnitude only. So which means magnitude of R2 bar minus R1 bar, and next here unit vector I have previously and later I have converted that. So of course this is cube, this magnitude cube followed by R21 bar means R2 bar minus R1 bar. So like this we write in terms of vector, in terms of vectors. So force on 2 because of 1. If you do reverse, F12 bar, it's the same but opposite direction. So same, Q1, Q2 will be same. Magnitude R1 bar minus R2 bar followed by, instead of R2 minus R1, you have R1 minus R2. Nothing more than that, that's it. That's it. So this is a vector form of Coulomb's law.